Dear students, today we start another problem of Fourier series. So, same types of problem. Last class it was solved x sin x, and now we consider x cos x. Same problem, same types of problem. Now, this is x cos x. X cos x, this is obviously odd function because cos minus x equal to plus cos x and x minus x equal to minus x. So this will be odd function. If it is odd function, then no need to find a0 and an. Directly you have to find bn. So solution is that since fx equal to x cos x is an odd function, this is an odd function, therefore a0 equal to 0, an equal to 0. So now we have to find bn. bn equal to 2 by pi integration 0 to pi fx sin nx dx. These are bn. So 2 by pi 0 to pi fx means x cos x sin nx dx. So this is 1 by pi 0 to pi x. This 2 we write within this bracket. This is 2 sin nx cos x dx. So we write this 2 is here. Sin is first. This is cos second. Now we know this formula 2 sin a cos b. This is sin a plus b plus sin a minus b. We know this formula. 2. So we know this formula 2 sin a cos b equal to sin a plus b plus sin a minus b. So we assume this is 2 sin a cos b. 2 sin a cos b. So this will be 0 to pi x. 2 sin a cos b means sin a plus b nx plus x. This is a, this is b, plus sin a minus b nx minus x. So this is dx. So this will be 1 by pi 0 to pi x sin, taking x common, n plus 1 x dx, and again this is 1 by pi 0 to pi x sin, this is x common, n minus 1 x dx. We get this one. So this is our by parts formula. So by parts formula, we can use this formula. This formula we know uv. This is shortcut formula. This is u v1 minus u dash v2 plus u double dash v3 minus dot dot dot. This is plus minus, and v1 means integration v, v2 means integration v1, v3 means integration v2, and u dash means ddx of u double dash means ddx of u dash, just like this. So using this formula we get, so this is by parts formula. If you are using by parts formula, this is 2 times we have to integrate. Now we are using this formula. By using this formula, so 1 by pi, this is u. U means x. v1 integration sin nx means minus cos nx by n. This, and minus u dash. U dash means ddx of x is 1. And v2 means integration this. Integration cos means sin. So sin nx by n. This n and another n plus 1 is here. So n plus 1 whole square. So we get this, and this limit is 0 to pi. 0 to pi. Plus 1 by pi. Here also using same formula. X integration sin means minus cos n minus 1 x by n minus 1. This is x, uv formula x. Integration sign means cos. This is cos minus cos, and again ddx of x is 1. This is cos, integration cos means sine n minus 1 into x by n minus 1 and n minus 1 n minus 1 whole square, and this is the limit 0 to pi. Now we rewriting this line 1 by pi minus x cos n plus 1 into x by n plus 1. This is minus minus plus sine n plus 1 into x by n plus 1 whole square 0 to pi 1 by pi minus x cos n minus 1 into x by n minus 1. This is minus minus plus sine n minus 1 into x by n minus 1 whole square 0 to pi. We get this one. Now putting the upper limit, putting pi here, 1 by pi minus pi cos n plus 1 into pi by n plus 1. This is sine n plus 1 into pi by n plus 1 whole square. This one we get minus, if we putting lower limit, then lower limit here 0, cos 0 is 1, then this is 0, sin 0 0, directly we write 0, minus 0 plus 0, we get this. And here 1 by pi, putting upper limit pi minus pi cos n minus 1 into pi by n minus 1 sine n minus 1 into pi by n minus 1 whole square. This one we get minus 0. This is 0, this is 0. So 0 plus 0 we get this one. 1 by pi, this is minus pi minus 1 to the power n plus 1 by n plus 1. This is sine n pi 0. We get this, and this is cancelled. 1 by pi, this is minus pi cos n minus 1 into pi. This will be minus 1 to the power n minus 1 by n minus 1 sine this pi. This is 0 and this one cancel. So at last we get pi cancel, minus 1 to the power n plus 1 by n plus 1. This is minus 1 to the power n minus 1 by n minus 1. We get this one. Now so this is we get. Now minus 1 to the power n plus 1 by n plus 1, and this we write, this is power is n plus 1. Here also you have to find n plus 1 power, n plus 1, and this is minus 1 to the power 2. This is minus 1 to the power minus 2. Then this is n minus 1. This will be minus 1 to the power n plus 1 by n plus 1. This is positive. This will be minus 1 to the power n plus 1 by n minus 1. And this minus 1 to the power n plus 1 is common. Then we get 1 by n plus 1 plus 1 by n minus 1. We get this. Then minus 1 to the power n plus 1, taking LCM n plus 1, n minus 1, this is LCM n minus 1 plus n plus 1, we get this. Then this 1 cancel. So minus 1 plus 1 cancel, n twice n. So we get twice n minus 1 to the power n plus 1 by n square minus 1 we get. So this will be n plus 1, n minus 1, n square minus 1 we get. So next, so we get, this is Bn equal to this one. So here we get, if n is even, if n even, then we get one condition. N even means this is suppose 2 plus 1 is 3. Then at that time this will be 3 means minus 1 get, minus plus we get. So we get two conditions we have. Bn equal to, we get minus twice n by n square minus 1 if n is even but n not equal to 1. So again we get Bn equal to, here we get, if this is odd, suppose 3 we get, 3 plus 1, 4. 3 plus 1 is 4. If it is 4, then minus 1 to the power 4 means plus 1, we get minus twice. So if it is odd, suppose 3 plus 1 is 4. So if n is even, I recall this, n is even means suppose 2 plus 1 is 3, then minus 1 to the power 3 means minus 1, that minus is plus, we get this will be plus. This is plus we get. Again, if it is odd, suppose 3 plus 1 4, then minus 1 to the power 4 means plus 1, then we get minus twice n. So this will be minus twice n by n square minus 1 if n is odd but n not equal to 1. We get this. So we have this condition, but we can't put n equal to 1. If we putting n equal to 1, then denominator will be 0. So except 1, we can putting other values also. Now we have to find Bn. Again, Bn means 2 by pi. I recall this first line, 2 by pi 0 to pi x cos x sin nx dx. So Bn, B1 we find from this relation, B1 2 by pi 0 to pi x cos sin 1x dx. This is 1 by pi 0 to pi x, 2 taking here, so 2 if we taking here, then 2 sin x cos x dx. So this will be 1 by pi 0 to pi x 2 sin a cos a means sin twice a. We get this one. Again using bypass formula, 1 by pi x integration sin means minus cos twice x by 2. So this is ddx of x is 1. Again integration cos means sin twice x by 2, and another 2 is 4 we get, 0 to pi we get, and 1 by pi minus x cos twice x by 2 plus sin twice x by 4, we get upper limit if we putting, then we get 1 by pi minus pi cos 2 pi by 2, this is sin 2 pi by 4, we get this. And if we putting lower limit, this is 0, this is 0, so we get 0 plus 0, we get this one. So this is 1 by pi, this is minus pi, this is cos twice pi is 1, this is 2, and pi cancel, minus 1 by 2 we get. So we get 1 by 2. Next, this is our value, Bn equal to, at last we get Bn equal to minus 1 by 2. This is the Bn. Now we putting the value here, we putting even value here, odd value is here. So first putting even value, B2 2 into 2 square minus 1, this is 4 by 2 square minus 1, and this is putting here, again putting 4, B4 2 into 4 by 2 square 4 square minus 1, then this is 8 by 4 square minus 1, and B4 is 8 by 4 square minus 1. Next we find this B3 equal to minus 2 into 3 by 3 square minus 1, this is minus 6 by 3 square minus 1. So we can find B5 minus 2 into 5 by 5 square minus 1, this is minus 10 by 5 square minus 1 ... We can find in this way. Now by Fourier series we have f of x equal to a naught by 2 summation a n cos nx d cos nx plus summation bn sin nx. We get this. So this we know a naught is 0. This is odd function a naught 0, 0, and this is also 0, this one. Next we find only this b1 sin 1x plus b2 sin twice x plus b3 sin thrice x plus b4 sin 4x plus dot dot dot. We can write in this way. And fx means x cos x. This equal to b1. b1 we know b1 is minus half. b1 is minus half we get. This is b1. b1 is minus half plus b1 minus half. This is sin x. And b2 we get 4 by 2 square minus 1. So this is 4 by 2 square minus 1 sin twice x plus b3 means 6 by minus 6 by 3 square minus 1 sin twice x plus b4 means 8 by 4 square minus 1, 8 by 4 square minus 1 sin 4x. We can write several values. So this will be x cos x equal to minus 1 by 2 sin x plus 4 by 2 square minus 1 sin twice x minus 6 by 3 square minus 1 sin thrice x plus 8 by 4 square minus 1 sin 4x minus dot dot dot, and this is our answer. This is the complete solution of the Fourier series. X cos x we can write in this way. So this is the complete solution. Thanks.